Okay, this is a connected rates of change calculus question, and the thing to watch out for with these questions is to go from what we know and then convert that into what we want. So what we know in these questions always changes to what we want, and organise the information carefully. So what we know, this is about a sphere, and it says the volume is increasing at a rate of 25. A rate, now that is a gradient, a rate of increase, dv dt. The rate of increase of volume is 25. Of course, that's not the only thing we know here. We also know that we're dealing with a sphere, and the volume of a sphere I know to be 4/3 pi r cubed, and I also know the surface area of a sphere to be 4 pi r squared. If I differentiate these, I've got v, I've got r, so I can differentiate to give me dv dr, and it's the r that is the variable, so keep your eyes on the r. So that's 3 times 4/3 pi, and drop the power, r squared, and differentiate the a. Again, r squared becomes 2r, so that becomes 8 pi r. So I've got three things, this, and this. I know all those. And the question is now, what do I want? Well, I want the rate of increase of the surface area. So what I want is, I want dA dt. Combinations of these. Well, I've got certainly a dA dr. I've got that, and that will give me the dA, but I don't want this dr. So think in fractions here. To get rid of the dr, I need to multiply by something with dr on the top to get it cancelling. So multiply it by dr, and what have I got? Well, the only thing I've got there is a dr dv. Okay, so the dr will go, but now I've got a dv that I don't want. Let's get rid of a dv. I need a dv, and for that I've got a dv dt. And just check that these are going together right. So my drs would cancel, my dv's will cancel, and I've got all three of these. So let me slot all those in. dA dr, 8 pi r. dr dv. dr dv is this thing upside down, so that is 1 over 4 pi r squared. And dv dt I know to be 25. Right, let me sort all this out. Pi's cancel, r cancels with r squared. 4 into 8 is 2, and what I have left is 50 over r, and so final answer. R equals 2.5, rate of increase, dA, area with time, dA dt equals 50 over 2.5, which equals, I believe, 20. And units, centimetres squared per second. There we go. Combinations of what we know to give us what we want.